In this section, we will discuss the built-in message routing capabilities of Azure IoT Hub. In this section, we will look at two concepts regarding Azure message routing: endpoints and routes. IoT Hub message routing enables users to route device-to-cloud messages to service-facing endpoints. Routing also provides a querying capability to filter the data before routing it to the endpoints. An IoT Hub has a built-in endpoint. You can create custom endpoints to route message to by linking other services in your subscription to the hub. When you use routing and custom endpoints, messages are only delivered to the built-in endpoint if they don't match any query. To deliver messages to the built-in endpoint, as well as a custom endpoint, add a route that sends messages to the built-in events endpoint. There are a few built-in endpoints to build applications against provided by Azure IoT Hub. The IoT Hub resource provider exposes an Azure Resource Manager interface. This interface enables Azure subscription owners to create and delete IoT Hubs and to update IoT Hub properties. IoT Hub properties govern hub-level security policies as opposed to device-level access control and functional options for cloud-to-device and device-to-cloud messaging. The IoT Hub resource provider also enables you to export device identities. Each IoT Hub exposes a set of HTTPS REST endpoints to manage device identities: create, retrieve, update, and delete. Device identities are used for device authentication and access control. Device twin management is where each IoT Hub exposes a set of service-facing HTTPS REST endpoint to query and update device twins, or update tags and properties. Each IoT Hub exposes a set of service-facing HTTPS REST endpoints to query and manage jobs. For each device in the identity registry, IoT Hub exposes a set of endpoints. And each IoT Hub exposes a set of endpoints for your solution backend to communicate with your devices. With one exception, these endpoints are only exposed using the AMQP protocol. The method invocation endpoint is exposed over the HTTPS protocol. Under the device endpoint, there is send device to cloud messages. A device uses this endpoint to send device to cloud messages. There's the receive cloud to device messages. A device uses this as well to receive the targeted cloud to device messages. There's an endpoint for initiating file uploads. A device uses this endpoint to receive an Azure Storage shared access signature URI from IoT Hub to upload a file. You can retrieve and update device twin properties. A device uses this endpoint to access its own device twin properties. And there's one to receive direct method request. That's where the device endpoint gets the direct methods. These endpoints are exposed using MQTT version 3.11, HTTPS 1.1, and AMQP 1.0 protocols. AMQP is also available over WebSockets on port 443. Under Service Endpoint, there is Receive Device to Cloud Messages. This endpoint is compatible with Azure Event Hubs. A backend service can use it to read the device cloud messages sent by your devices. You can create custom endpoints on your IoT Hub in addition to this built-in endpoint. There's an endpoint to send cloud-to-device messages and receive delivery acknowledgments. These endpoints enable your solution backend to send reliable cloud-to-device messages and to receive the corresponding delivery or expiration acknowledgments. There's the receive file notifications endpoint. That's the one where you receive notifications when your device successfully uploads a file. The direct method invocation. This endpoint allows a backend service to invoke the direct method on the device. And you can receive operation monitoring events. This endpoint allows you to receive operations monitoring events if your IoT Hub has been configured to emit them. You can link existing Azure services in your subscription to your IoT Hub to act as endpoints for message routing. These endpoints act as a service endpoint and are used as sinks for message routes. Devices cannot write directly to the additional endpoints. At the time of this recording, IoT Hub currently supports the following Azure services as additional endpoints. It supports Event Hubs, Service Bus Queries, Azure Service Bus Topics, and Azure Storage Containers. In the next section, we will demo using a custom endpoint. In this section, we will create an endpoint for a Service Bus topic. We will use it to create a route for the humidity data. Let's get started. Let's create a new service bus instance by using the Azure Marketplace again. So let's go to our Pluralsight resource group. We're going to click Add, and we're going to click Create once we search for Service Bus. We need to add a unique name. We'll select the pricing tier, subscription through Movie Magic. We'll go ahead and instantly deploy it. It may take longer when you do it. Now you'll notice we can't add a topic, and the reason we can't add a topic is because we're on the wrong tier. Once we set the standard tier, we can then add a topic. Let's go ahead and give this topic a name. We'll call it the IoT topic, and we will enable partitioning. Now let's go to our IoT hub. Let's scroll down to message routing in the left-hand menu, and let's add a route. In our route, we have a name, endpoint, data source, whether the route is enabled, and a routing query. So for the name, we're going to call it the topic route. So let's add that endpoint. We're going to select the service bus namespace of the service bus we just created, the Pluralsight demo, and then we're going to select the IoT topic. We'll name the endpoint topic endpoint, we'll create it, and then that will allow us to create the route as well. With the route complete, let's go ahead and create our subscription to the topic. So let's, again, create a name, IoT demo, and we will just go ahead and accept the defaults and create this subscription. We're going to use this subscription in our Azure function to listen for that routed data. So we need to grab the connection string for the shared access policy out of the portal. So let's go to the shared access policy tab. Let's select the one available, and we'll use that one. With all of that complete, let's comment out the function name attribute on the IoT hub function just so that we only have the one function running. And then let's go ahead and debug our topic listener. Once that's up and running, you see the new data that is being routed through our new route and endpoint so that we can listen to the topic instead of listening to the event data directly off the hub. In this module, we looked at IoT in Azure, focusing on Azure IoT Hub. While exploring Azure IoT Hub, we looked at using it as a cloud gateway for its device management capability and how it is reliable, secure, and how it can scale. After looking through those features, we looked at how to use the data we are sending to Azure IoT Hub with other Azure services and custom code. Finally, we saw how to route messages in Azure IoT Hub. In the next module, we will look at hot, warm, and cold data streams and how they are implemented in Microsoft Azure.